Hi everyone. Let's talk about section 12.2b. So since we've already talked about 12.2a, which was how angles work and counterclockwise is a positive direction, coterminal angles, today we're going to talk about a different way to measure angles. We're so used to 360 degrees. So notice in tiny print it says the objective is to convert between degrees and radians. Radians is a whole different way of measuring. It's kind of like temperature. Here we measure in degrees Fahrenheit. In Canada it's degrees Celsius, but it's still the same temperature outside. So it's a similar situation. So first of all, before we can talk about radians, let's talk about a unit circle. So a unit circle is a circle with a radius equal to 1 unit. 1 inch, 1 centimeter, 1 mile, whatever. It's always 1. So if you notice on the diagram, I've got myself an angle. Remember, theta means an angle. So I've got this radius from the center to the circle. It is 1 unit. So we use that measurement and we say, of course, the center of the circle is at the origin. Everybody knows the circumference of a circle formula, right? Circumference is equal to 2 times pi times r, the radius. And 1 radian, we're going to use that 1 radius. And 1 radian is equal to the measure of an angle that intercepts the circle and has an arc length of 1 unit. We've been talking about some geometry stuff here in the last few days. Arc length is how long it is along the outside of the circle. It's not the whole circle, but it's a part of it. So if I took this arc length right here that we've got in red, but I measured out 1 radius, or a radius of 1, those would be equal lengths. So I would measure out another radius. I would measure out another radius. I would keep going until I got all the way around the circle. So 1 radian is, 1 radian is that measure that is the same as the radius 1 of the circle. It's kind of weird to think about. So the question then is we have to think about how many radians to get around the circle. We know 1 complete revolution is 360 degrees. So how many radians would it take to get around the outside of the circle? So let's think that through for a second. So circumference. The circumference of a unit circle in radians looks like this. We know that our radius equals 1, right? 1 unit. So if I use my circumference equals 2 times pi times r, and I substitute that 1 in, my circumference in radians is 2 times pi. So we know 1 complete revolution is 360 degrees. We know that 1 complete revolution in radians is 2 pi radians. Everybody knows what pi is, right? Some of you know more digits than others. So 2 times pi, 2 times 3.14. So it would take about 6 of those little radians, just a little bit more, to get 1 complete revolution. But we're not worried about that. We just want to know 360 degrees or 2 pi radians. That is the degree and the radian measures. So remember, degrees and radians measure the how far the angle goes around. All right, so here's how we do this. In order to convert, let's say from radians to degrees, let's say I give you, I'll put an example. Let's say I give you pi over 6, and I want to know how many degrees that is. I need to be able to picture it, maybe draw it. I say, oh, draw an angle that is pi over 6 radians, and you're like, I don't know how big to make that. So here's our formula. You're going to take your radians times 180 over pi. Multiply your radians times 180 over pi. So if I take my pi over 6 and I times by 180 over pi, what happens to my 2 pi's? They're going to cancel out, right? When you go to your calculator, you're probably going to do 180 divided by 6 or 180 over 6. So pi over 6 radians is equal to 30 degrees. So what if we want to go the other way to convert from degrees to radians? Let's say, for example, I say, tell me how many radians is the same as 45 degrees. And you're like, I have no idea, so here's your formula. You're going to multiply your degrees by the reciprocal of what we just used, so pi over 180. We have to put the pi into the problem, so that's why the pi is on the top. To go from radians to degrees, we have to take the pi out of it, so we cancel them out. So if I've got 45 degrees and I want to turn that into radians, I'm going to multiply that by pi over 180. Remember, if you want to think of it as 45 over 1, do that. The pi doesn't go away. We know in radians we have a pi in our answer. So I'm going to go to my calculator. I'm going to just know that I used that pi. I'm going to put that in my answer just like if it were an x. And I'm going to do 45 over 180 or 45 divided by 180. You're always going to keep these in fraction form. Improper, whatever. Don't go to decimals. Don't go to 1.2 radians or something like that. So 45 over 180 is going to end up being, did you get it yet? I think it's going to be a pi over 4. So, or 1 pi over 4. So maybe you got 1/4. So 1 pi over 4. Remember, the pi always goes back into the numerator. So I'm going to ask you to do some things, and I might say, oh, draw me this angle, but it is 2 pi radians. Well, you need to know how many degrees that is, unless you've got it figured out, so we need to be able to convert that. I might ask you about what's a coterminal angle to pi over 3 radians. So the easiest way for a lot of us, at least at the beginning, is to turn that pi over 3 radians into degrees, and then we can find a coterminal angle because we've done that already. So change the degree measure to radians. Let's do one quick one. Let's do a negative. Let's do letter B. So negative 160, I want to turn that into radians. So I'm going to multiply by pi over 180. Is your answer going to be positive or negative? Going to be negative. You're going to have a pi in it. And you're going to ignore the pi for a second. You know you're going to have a pi in your numerator. And you're going to go to your calculator and probably do something like negative 160 over 180. Let your calculator simplify. Keep it in fraction form. And I got negative 8/9 pi. Keep that pi in the numerator. Don't change it to a negative 8/9 pi on the side. So let's do, I don't know, let's do pi over 12. Let's do 2a. Change the radian measure to degrees. So what do we multiply by when we're changing radians to degrees? 180 over pi, because we always like these pi's to cross out. So I'm going to go to my calculator. I'm going to let it do the work. 180 over 12 or 180 divided by 12. And I'm pretty sure that one comes out to 15 degrees. If we did letter B, multiply by 180 over pi, the pi's cross out. I'm going to go to my calculator. I'm going to do 9 times 180 and then divide that by 5. So just let the fraction do the fraction, or do 9/5 times 180. Let that work for you. Somebody do the math. Let me know what you got. All right. So now let's kind of look at what we can use this for. So it says find one positive and one negative angle measure that is coterminal. I'll probably even ask you to draw them. But if we look at example A, 7 pi over 3, would you like to turn that into degrees? Is it easier for you to think about that in terms of degrees? If so, let's do that. So I'm going to times by 180 over pi. I'm going to let those pi's cancel out. I'm going to go to my calculator. I'm going to let my calculator do the math for me. And anybody got that calculated out? Pretty sure that's a 420 degrees. So what did we do to find positive and negative angles? If you want to draw it, we could do that. 420 is obviously more than one rotation, right? So it's an extra 60 degrees. So here's my initial side. There's 360 plus another 60 degrees to get to 420 or 7 pi over 3. So one positive and one negative. I think sometimes for numbers that are bigger than 360 or bigger than 2 pi, one complete revolution, it's easiest to get this by using a diagram. Because my question to you would be, how many degrees did we go past that original initial side? That's 60 degrees, right? So 60 degrees has the same terminal side. So there's a coterminal angle. What if I went this direction? What if I went in the negative direction? How many degrees would another coterminal angle be? Well, I'm going negative, so I'm pretty sure that would be negative 300 degrees. When we find positive and negative coterminal angles, when we're dealing with degrees, we typically add and subtract 360 degrees. If we're dealing with radians, we add and subtract one complete rotation. So if you'd rather add and subtract 2 pi, feel free to do that. If you'd rather turn it into degrees first, do it that way. So whatever way works the best or seems the easiest to you, please do so. But remember, coterminal means it has the same side, the same arrows. It just goes extra revolutions or it goes in the negative direction. All right. I think that's good. Have a great day. We'll see you next time.